Okay, guys, lovely to see you in another video. Today, we are going to take something really hard, which is after the two sum, we are going to take the add two numbers, which is specifically you can use this um, in a situation where you don't use array. So, I was thinking. So usually they say this dynamic linked list is basically for like storing dynamic data. So I was thinking in JavaScript it's dynamic. Array is kind of dynamic in the sense you don't define a fixed length. So what was the difference? So I was thinking and I figured out basically it's if you're using an insert or a update operation, a frequent something like that, it's better to use linked list. Basically, because if you go to a linked list, you have the reference, right? You have the reference. You just need the reference. You don't need the whole array. So that's basically, I think that's the place where you would go for a array. A linked list. So let's go through this. This is a very pretty neat question. You are given two non-empty linked lists representing two non-negative integers. So they have given two arrays. Basically, what they mean is this is a integer, non-negative integer, and this is one another non-negative integer. Both are non-negative, non-empty linked lists. The digits are stored in reverse order. So 342, that's how it's stored. 6465 is the number, so it's stored in reverse order, and each of their nodes, it basically has a really good purpose for this, but we'll go to it later. And each of their nodes contains a single digit. Each of their nodes that's fine, it's considered one node. Add the two numbers and return the sum as a linked list. So I am going to add 342 plus 465, and I am going to return the sum, which is 807. So that's basically what they mean here. You may assume the numbers do not contain any leading zero except the number 0 itself. So basically what they mean is it's going to be a 3-digit number, not like you are going to have a 043, something like that. Are we going to have a 043? But you can have 0. You can have 0, but not like something like 048. So here you can see that 99999999, and this is probably 9 million, I guess. Actually, it's 90 million, 999 something, and 9,099 something, and it adds up to this, which is 1 billion, I guess. Yes, something like that. I'm not sure of the billion part, but yes. Okay, let's move to the solving part. Okay, so this is how we define a list node, which basically means a linked list is made up of a node which have the reference to its next node. So that's basically how we define a linked list. Shall we expand this? Yes, that'll be great. So let's go to the Miro board. So what we have to do is we have to first create a temporary a head node, right? A head node. So then I refer to this head, create a dummy version, like copy of it. So what will happen is this will be the node and this will act as a pointer. So each time I get the sum, I will, if there's a carry, I will carry to the next sum. But likewise, this temp will act as the pointer for my the result array. So basically, after summing this, I will add that here, let's say value 6, then I will add let's say this was 16, and I will carry the 1. Let's say the sum will be 3, I will add this 4, something like that. So based on temp I will be moving, and at last I'll return the head, which will basically point to the head. Yeah, let's do it. So first I'm going to create something called let's create a new const head new list node. Okay, and I'm going to create a reference to the head. Okay, then I'm going to have a carry as 0. Now I'm going to check whether there is a L1 which is not equal to null, or L2 which is not equal to null, and then the biggest part, carry, is not equal to 0. Okay, so if any of this condition passes, it will actually this is not an if, this is a while statement. While this is true, it keeps on looping. Okay, we are into it. Let's get the first value, which is, let's have consider value 1. So value 1 going to be L1 dot value. So let's check if the value first there. If it is there, we will put L1 value, or else we will give null to it. Do the same to the second as well. L2 value, L2 value null. Okay, got that correct, I guess. Let me quickly check this. Yeah, still working. Now what I need is, I need the sum, right? I need the sum. Sum is going to be value 1 plus value 2 plus the carry. Okay, whatever in the carry is currently 0, but we will change the carry. So what is going to be there in the carry? We will get the lowest value divided by sum minus 10. So what exactly I am talking about? So let's do, let's think of a normal calculation. 342 plus 465, right? Where is it? Nobody cares. 465. So how do we solve it? This is the part why this question was in reverse link. So when we are adding, we don't just add like this 3 4, we add from the reverse part. So 2 4 7, then if it is 10, we just put 0 and carry that 1 forward. So exactly we are doing the same here. We are in this here. We will get the carry will be 1. Let's say it's 11 and the carry will be 1, and the current value is actually stored in the next one now. So what will happen is, we probably will have to have the sum. We will create a new node here. Okay, node. So we need to create a node, and in that node we will have some remainder 10, which is, let's say if it is 11, it will be 1 here. That's the remainder. So with the 1, we'll create a new node and we will make the current node to the next. So the next node will be the current. So now I'm going to iterate again. Now I will go move to the second one by doing this. I think that's pretty understandable. Comment if you don't understand. Yeah. So I guess we have come to the end, and all I have to do is I have to return the at last when the loop finish head.next, which is the reference to the head. Likewise, what as I said, you don't need to return the whole head. You just okay. Now what we have to do is, if the L1 is not equal to null, what we have to do is L1 should also become L1.next, because we have to move to the next guy. If L2 is equal to null, we have to move this guy to the L2.next. Lost it. Run it again. Yep. So you got the issue, right? You first get a head, you have a pointer to it, pointer, then you have the carry, then you check, you get the value, you add it here, you get the probably 10 plus 1 carry will be 1 11. So 10 plus 11, it's 10 point something and 1 point something, and the carry will be 1. You get the node here. 1 will be the current value, and you move the cursor, pointer, pointer. Okay, I know pointer is wrong, but I'm gonna change it just. Okay, see you in the next video.